Hi all, and welcome to day 21 of Advent of Elixir. Today I'm going to show you a few ETS tables odds and ends. So in a previous video, which I'll link to below, I showed you how to read a ETS table, ETS match spec. And I decided it'd probably be also a good idea to at least make one video where I go through the process of building up an ETS table from scratch that you can use. So in this case, what I'm going to do is I'm going to show you a singleton ETS server. I'll explain what I mean by that in a bit, but the point is that you can use this as a neat KV store to keep odds and ends in your application, and with a little bit of work, you could probably use it as a cache, although I won't go over any sort of eviction logic. So if you want to figure out how to evict things from your cache, that's going to be on you. It's certainly easy to do, and I've done it without having to resort to library solutions like Elixir or CacheX, which might bring in the whole a lot more than you care to do. Okay, so let's take a look. So the first thing to note is that an ETS table needs to be owned by a particular process. So in this case, since we're going to want this process to basically live, what we want to do is we want to make sure that it's got at least some sort of OTP hardiness behind it. And I'll show you why we want to do that in a moment. So what we're going to do is we're going to write a start link, which is a gen server start link, as you normally would with a gen server. Although in this case, you really don't need any parameters at all. We'll have an init, and remember the start link is executing inside the process of the calling function that is requesting the new gen server to be created, and the init function is running inside of the new gen server. We run ets.new, which creates a new ETS table. And I'll go over these parameters in a moment. And then this process, the gen server process, will then own the ETS table that we created. Then I just return OK. We are not going to actually store any state. And for me, the default thing to store when you have nothing is empty list. That turns out to be the smallest term in Elixir land, or in the Beam virtual machine. And then I give a hibernate instruction. I'm not sure if this is actually necessary because I think that the gen server will probably get hibernated anyways. But this just tells it I don't intend for any messages to arrive at this gen server because we don't intend to send any messages. So set tells you that this is just going to be a list of tuples where one of the tuple items, in this case by default the first element in the tuple, has to be unique. And what this will allow us to do is it'll allow us to overwrite keys, because if the first element of the tuple is the same, that constitutes an overwriting, and we can replace values that way. Public means that any other process can access the ETS table in a both read and write fashion. You can do protected, which means that other processes can read the ETS table, but only the owning process can make a write operation. And you can also have one where it's private, which means that nobody except for the owning process can write it. So I find that private ETS tables are kind of rare. You're only using them when you need a mutable data store, a mutable high-performance data store, because something like a map where you're rewriting the whole map every time is just going to be too slow. And that can happen. And the last thing is named table. So normally, if you want other processes to access the ETS table, you will have to return the table ID that the ets.new function creates. that's going to be a reference. And you pass this table ID around as a token that allows other processes to access the ETS table. So that's what you would use in the case of public or protected in certain cases. But in some cases, you may want it to be sort of like a globally accessible service that you're having. This KV table is something that I want anybody to access without having to ask the owning process for permission to find it. And so when you do name table, that's like creating a giving it a name like DNS so that everybody knows what the name of the ETS table is, and they can access it no matter which process they're in. Okay, so here I have two different. I've implemented two different functions: the put function, which will insert the key value tuple into the ETS table, and see here I'm calling module, which is advent, and that is going to be the name of the table. And because I have named table, instead of sending a TID, I can call it using this module atom. This is the globally known name for this ETS table. And so when I do run a put and a get, I don't have to have the thread that I'm calling or the process that I'm calling put and get from communicate in any way with the owning gen server in order to manipulate the table. And then let's look at get. So get here is pretty simple. We're just going to pass the module, which is the well-known name. Then I'm going to call ets.select, and then I'm going to select $1 for the first element in the tuple, $2 for the second element in the tuple. $1 has to match equally the key that I supply. Let's just say that it's got to be an atom, so I don't have to wrap that inside of a literal tuple. And then I'm going to just return $2, which is the second element of the tuple, right? So the value. And then what we're going to do is this is going to either give us an empty list if there's nothing in there, or the value if there was that key there. So list.first will either give me nil if that key value doesn't, or if that key doesn't exist, or it will give me the value. So let's take a look at this running. So in my application, I've had the application supervisor run the advent process. That kicks off the advent process, right? And so that should be running. So this new IEX console, which hasn't seen anything else, is now able to just call advent.put, and then let's just put foo 47, right? That'll work. And then if I do advent.get, it'll say 47 because it knows what that value is. And if I do something that doesn't exist, it'll give me nil. So this is basically just exactly what you expect. It's a KV store. So I do want to show you one thing. Why did we want to bother putting this into a gen server? Well, I think that there's a really cool thing that we can do, right? So what I'm going to do is I'm going to add one option here, which is to name this gen server as well. We're going to name it the module. The next thing we're going to do is we're going to allow us to do a reset button. And so what we're going to do is we're just going to gen server.cast module, and then we're going to cast a reset token. So because we've named this gen server, now this gen server also is a globally knowable item. And don't worry, the namespaces for gen servers and the namespace for ETS tables, You can overload them. It's not a problem. So it's not going to be a problem that both of these are named Advent. And then what I'm going to do is I'm going to do a def handle call or handle cast reset. And then we don't care about the state. And then when we hit reset, we're going to return stop, normal, and nothing. So what's going to happen is when we hit reset, it's going to send the named Advent process a reset message. That reset message is going to be trapped by this handle cast, and all it'll do is it'll stop the process. Now, why does this wind up resetting the ets table? Well, let's take a look. So I'm going to kill this and then start it again. So let's add some value in, advent.put foo47, and then advent.get foo. Great, it works. Now I'm going to do advent.reset. And that should have killed the process. And then if I get advent.get foo, there's nothing in there. So how did that work? Basically, remember that the old process owned the ets table. And then when we hit the reset button here, it stopped that. That process terminated itself. Then the application supervisor restarted the Advent process, right? And then that created a new ets table. And so this is why you want to generally wrap your ets tables inside of a gen server, because you get the nice OTP constructs that allow supervisors to do the right thing with your wrapped ets process. I want to show you one last thing, and this is for code readability. And this is especially useful if you start writing ets tables that have more complicated tuple structures for their data storage. So if you recall when I was describing this get function, it's not entirely intuitive what exactly is going on here. So I'm going to show you a nicer way of doing this. I'm going to name key to be this atom, and I'm going to name value to be this. So these are symbolic representations that are just going to substitute in for these variables. And the nice thing is this makes these named variables, even though they are constants. And now it's much, much more evident what's going on here. I'm going to match key and value tuples. I'm going to check if the key part of the key tuple is equal to key. And I'm going to return a list of values as the final result. I think that this is a much, much more useful way of notating it. All it does is requires you to have just a little bit of indirection in terms of using these module attributes. Of course, if we recompile this, you'll see that advent.put foo47 advent.get foo. It still works. Okay, that's all I've got for today. Hope you found this to be useful, and I will see you tomorrow.